Hello class, this is Tom Holmes, and today we're going to be talking about solving equations with variables on both sides of the equation. Okay, so right now, if you know that this 3x plus 4 equals 13, this is the same type of equation that we talked about last time, but there's a new different equation right here, and I want y'all to think about what's the difference between those two. So take a minute to pause this video and just think about what's the difference between these two. Okay? So now that you got time to think about it, I'm hoping that you actually got this. Is that this bottom equation has variables on both sides of the equation. It has one on the left side, one on the right side. But if you notice at the top, this only has one variable term, and it's mainly on the left side. So really what I want you to focus on is the top has only one variable, bottom has variables on both sides, okay? That's what I'm really hoping that you guys would actually notice. That, again, this bottom equation, it has variables on both sides of the equation itself. I'm hoping that you guys actually notice that. So this is going to be a little bit tougher. This is going to be tougher to work with, but don't worry, we'll be able to work this out together. Now, there is two different ways to do variables on both sides, and I'm going to show you both ways by working. I'm going to work one way, and I'm going to work the second way. You do not necessarily have to do both. You can pick one or the other. It does not matter which that you prefer. Just pick one that works best for you, and we're going to go along with it. So the first one is just solving like an equation like we've been doing. Get the variable by itself, move, and then divide and add, subtract, multiply, divide accordingly. So first off, I want to get the variable on the left side. I can do it on the right side, but I also want to show y'all what to do with a certain number. So let's say I subtract 3x from both sides. This cancels out. The 3x minus 3x, that cancels out. So the only thing I'm left with on the right side is a 3. Now, 2x minus x gives me negative 1x. I don't do anything with the negative 2, so I just bring it down. Okay? Now, I do have a pot now. Negative 1x, or I could just simply say x, and I'll show that in the next step. Negative 1x minus 2 equals 3. Well, remember, what do I got to do with this negative 2? Well, since it's subtracting, I got to do the inverse of it, which is addition. So I'm going to add 2 to both sides. I didn't really give myself enough room, so this cancels out. I get negative x equals 5. Now, that's not my answer, okay? Because I got to have a positive x. So I'm going to rewrite it. You don't have to rewrite it like this. I just didn't give myself enough room. So, now, in order to get rid of this negative, what I want to do is I want to divide by a negative 1. So I'm going to divide both sides by a negative 1. So what happens is the negative will basically cancel out, makes it positive, so I have positive x. Now, 5 divided by negative 1, that's going to give me a negative 5. And that's going to be my answer. Okay? Now, I'm going to erase this bottom part so that way I can have enough room. I'll rewrite this once we get back to it. Okay? Now, the next step, another way of doing it, and you can work this out the same way, but there's another way of doing it. It's kind of more of a visual. So imagine, I'm just going to draw a line because it's kind of easier to see. So what you could do, you can draw 2 boxes like so. So I want to have two small boxes on the top and then one big box on the bottom. Same on the other side. Okay? So what I want to do is I want to get the variables. I'm going to write that in black. I want to get the variables on the left side and the terms that is just a number, those are called constants. So like for example, the 5 and the 20, those are constants, okay? Now, so let me show you what to do. So I'm going to put both variables into these boxes. So the 7c goes here, 2c goes here. But if you cross the line, you're going to change the sign, okay? So I cross the line, and I'm going to change my sign to a negative 2c, okay? So again, I'm going to take this 5, because it's a constant, I'm going to take it to this box right here. But notice that I crossed the line, I'm going to change my sign. And I don't cross the line with 20, okay? I don't cross the line, so this remains a positive 20. So now initially what I'm doing is I'm going to combine like terms. So I have 7c and a negative 2c. If I combine those together, that gives me a positive 5c. And I do the same thing here. Negative 5 and the 20, I combine them together to give me 15. I'm just going to erase this real quick. So now all I got to do, there you go, is I want to set them equal to each other. And now I got 5 times c, which the inverse operation for multiplication is dividing. So I divide by 5 to both sides, and I get c equals 3. And that's going to be my answer. So again, it doesn't matter which way you do it, just as long as one works for you, stick with that method. If this method works for you, perfect. If this method works for you, perfect. Just figure out which method works best for you and stick with it. Next, we're going to be talking about equations where we have to combine like terms. So for example, 6m plus 5 minus 7m equals 10 minus 5m plus 3. Now, there's a lot of combining like terms, but if you notice, we're going to combine like terms twice, okay? So, I'm just going to draw a line so we can separate. So on the left side, I got a 6m and a negative 7m that I need to combine. I got to combine those two, so I'm going to get negative m. I could say negative 1m, but it's just an invisible 1, okay? You don't have to put a 1 there. I don't do anything with the 5, so I just leave it alone. Next, I got a 10 and a positive 3. So I got a positive 13. I don't do anything with the negative 5, so I leave it alone. Now I'm going to move terms around. So I want to move this variable negative 5m and add it, because since it's negative, I got to add, because this is the inverse, or the opposite. So I'm going to add 5 to both sides. Since these two are the same terms, I'm adding negative m plus 5m, not 5 plus 5m. The 5m's cancel out, so I'm left with 13 on the right side. Negative m plus 5, that gives me 4m. And I have the 5 remaining, so I'll bring that down. Next, I gotta subtract this 5, because the inverse of the opposite of addition is subtraction. So I'm going to subtract 5 from both sides. So 4m, because they cancel out, is what's left on the left side. 13 minus 5, that gives me a positive 8. And since they're equal to each other, all I really have to do, I'm just going to erase that line. And really all I have to do, since it's multiplying, I'm going to have to divide. So m equals 8 divided by 4, which is 2. Okay? So bear with me, please. So this next problem we have, 4 plus 5x minus 6 equals 5x plus 2 minus x. That was weird, but we got to work out. Alright, now, again, I still got to combine like terms. So, think about which of these three terms are we going to, of those three terms, which one are we going to combine? And we are combining the 4 and the negative 6. So the first thing I want to do first, and I'll use this method in a minute, but I got to combine like terms first. So 4 minus 6, that's going to give me a negative 2. I don't do anything with the 5x, so I just leave it be. Now on this, between the three terms, I'm combining the first term and the third term because they both are x's. So 5x minus x gives me 4x. I don't do anything with the 2, so I bring it over down. So I bring it down. Next thing we're going to do is we're going to use that method. So draw your boxes, and if you need to draw a line so that way you know when to change sign, that's perfectly fine. So remember, I'm going to put all my x's together. So I'm going to put the 5x here, and I'm going to take this 4x over here. But remember, if I cross the line, I'm changing my sign. So instead of a positive 4x, it becomes negative. Now, I'm going to cross this negative 2, but since it's crossing the line, I'm changing the sign, which makes it positive 2. I'll bring this 2 down since I'm trying to bring it to, I'm trying to put all my constants on the right side, so I gotta bring that 2 over here. Now, combine like terms, 5x minus 4x, it's just a plain old x. 2 plus 2, that gives me 4. So I got x equals 4. Now, you could say, well, we got 1x. Yeah, but if you divide 1 to both sides, you're still going to get a 4. So really, as long as we just have this 1x here, or if it's just x by itself and it's just x, there's no number in front of it, you got your answer. Okay? So again, solving equations with variables on both sides is not too different than two-step equation that we've been working on yesterday, but the biggest thing is that it can be a little bit confusing which one to move. And that's why I introduced this method right here, because it kind of gives you a visual or a clear, clean way of figuring out which one moves in this side, which one moves to that side, just so that way you get an idea. Okay? So again, it doesn't matter which method you prefer. It doesn't matter if you use this type of method or this method in itself. Just as long as you're able to get the variable by itself in the end. Because remember, you gotta be able to combine like terms in for this method. You just gotta know which ones you gotta move. Okay? So just be aware of which term you're moving on one side or the other. Thank you.